You're watching the New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show.
Google Cloud helps organizations build quickly, securely, and cost-effectively with infrastructure that is optimized for the demands of AI, modern enterprise, and distributed workloads.
Hey everyone, live from KubeCon. We are here with the Google team. Hey all, how you doing?
Doing great, doing great.
How are you?
Good to see you, Alex.
Awesome. We've been talking for the past few weeks about this discussion today about Google Axion, and I would love to first of all, though, get some introductions. So Pranay, why don't we start with you?
Sure. I'm Pranay Bakre. I'm a Principal Solutions Engineer at Arm.
I'm Andrei. I'm part of Google Cloud. I'm a technical solution consultant, and I help our customers adopt our AI technology.
Okay. And Gari Singh, one of the product managers for Google Kubernetes Engine.
Well, excellent. So we're going to be talking about Google Axion and some of the news you have that just came out. I wanted to start by thinking of some context for our discussion today. And I always like to think of how do we get here? Now, of course, today, in the world that we're in, we're hearing so much about AI. But there's another side of things too, where workloads have increased tremendously over the past 10 years within cloud services. And the demands on workloads has increased significantly. Now, over the past years, we've started to see the arrival of new ways of thinking about models and how you think about their deployment, how you think about their development, how you think about their management. So with that in mind, I'm curious about your news and how it relates to where we are now and where we came from. And also, wondering if, Pranay, you could talk a little bit about the Arm story and how you came to this point today with Google.
Sure. You want to go first? Sure. Yeah, okay. So Arm Neoverse is our server class CPU architecture, which is what Axion is based upon. So we worked with Google. We started Arm Neoverse a few years ago, where we wanted to establish Arm as the industry leader in server class CPUs and grow the adoption for that. Now, Arm Neoverse architecture is energy efficient by design. So all the benefits you can get by deploying your workloads on Axion utilize that energy efficiency and power consumption gains. So, for example, developers now, since you talked about AI and workloads increasing so much in today's world, a lot of developers are deploying huge number of apps on the platform, Google platform. And Arm architecture supports that by providing that efficient architecture, so to speak.
So Andrei, maybe we can talk a little bit about Axion and a little bit about the historical perspective behind it, and and why it started, and what is significant about where we are today with the Axion processor.
Yeah, absolutely. Thank you. So Google has always had a history of custom silicon. We are dating back many, many years through our famous TPUs that were specifically designed to handle infrastructure for machine learning. But we saw a shift in data center needs and also a shift in public consumption. People wanted to have more performance at the lower cost, at the lower power consumption, so more data centers can have more compute. And as a result of it, we've invested many years ago into our first generation machine, which was ARM-based and called a T2A as an experiment for people to give it a try. But now we're seeing that our customers are ready to shift over to ARM, take advantage of better performance, pay less for the same performance, still get great reliability, and effectively get more for less. So with our introduction on the C4As, we launched them in many, many regions, and now N4A is bringing better price to performance ratio than C4A could do before.
Tell us about the M4A, either you, Andrei, you or Gary.
I guess the cool thing from the N4A perspective, from my perspective, especially coming from the kind of Kubernetes side of the house, right, where people love to mix and match kind of shapes of your pods that you're deploying out there. I think the great thing about the N4A really is we've introduced these things called custom machine shapes, if you will, or types. allowing you to basically mix and match how much memory and RAM you want, so no longer necessarily having fixed sizes, right? And I know we'll talk a little bit more probably later about some FinOps and things like that, but that's really one of the great benefits. And of course, it's just a general purpose, not just, but for general purpose workloads, right? So you're getting price performance for your standard microservices type workloads, which makes it super simple to switch it out for a majority of the applications that people are using today.
One of the things that's been noteworthy for us over the years is the rise of platform engineering. And it's still a very popular topic. And I think it relates directly to what you're talking about today, doesn't it? Can you tell us how this relates to the platform engineering story?
Yeah, I think, a lot of times, so there's multiple pieces, I think, to platform engineering. When it first sort of starts out, people are building like, what's the developer experience? What's the overall kind of platform that we're running on? But over time, as it grows, and if you're successful, one of the ultimate things that comes on is, price, performance, FinOps, et cetera, becomes one of those key things. Like, you're supposed to be building this centralized platform, optimizing all its usage. What's the cost of this? How are you optimizing price performance? How are you abstracting this from the developers? So as you start to look at that, obviously, if you can have the best price performance compute underneath the covers, you're going to meet those goals. So
again, Pranay, over the past several years, we've seen the number of workloads increase, right? I mean, it's just scaled, beyond what you could have imagined 5-10 years ago. And with that, we have seen the need for, ways to think about the costs a lot differently than you did with x86 chips, for instance. Tell us about that, a little bit about the shift to ARM and what has driven it, and where do you see that today?
Sure. I think I'll leave the cost bit to Andrei about Google Cloud, but I can talk about the shift from just x86 to multi-architecture. So we are promoting that message that you can develop your applications to be multi-architecture compliant, meaning that it can seamlessly run across both x86 and ARM at the same time. And again, like I said, the power efficiency is one major factor. And now Axion builds on that, both the C and the N series. So C is more designed for higher throughput and providing the maximum output that's out there, lower latencies, and N series is more about the general purpose compute, right? So we kind of cover the breadth of that spectrum. Now, as it comes to when people are deploying more and more towards this multi-architecture deployment, they are realizing the transition going from x86 to ARM, that you get much more compute, since it's theoretically you get a one physical core whenever you are deploying it in the cloud entirely. So you get more compute for much cheaper cost, but again, I'll send it over to Andrei, but you can deploy your applications in a much cheaper fashion, and we want to promote that message.
Great, so when you're thinking about, how you guys have built, the CPU around, with Axion, what do you think is special about it? What do you think is, you talked about the efficiencies and lower costs, but can you let's put ourselves in the shoes of a platform engineer, for instance, and the day-to-day problems that they face, right? They're managing multiple workloads, right? Tell us about that story and how you see that being then beneficial to that individual.
Right, so let's say you're talking about like platform, right, specific. So let's say you're building a CI/CD pipeline in your environment. With Axion, you can essentially deploy more workloads on top of it, because again, it gives you more cores and flexibility to deploy those, and you can add more, I'd say, efficiency around it. Whenever there are instructions that are optimized specifically, certain workloads like Java, Nginx, etc., they take advantage of those efficiencies and run much more faster and in an efficient manner. Because there are a lot of things like, I can go into instruction details like SV2,
right.
But I don't want to go there.
You can read that too.
Yeah, exactly.
Yeah.
But essentially, all of these workloads take advantage of that. That gets much more importance whenever you are doing, especially AI/ML workloads, like you are doing inferencing and others. That comes more into play when you are doing that.
That's interesting. So I'm curious then, Gary, about the M4A. And what did you hear from customers, in the past 12, 18 months? What were they telling you, or even longer than that, about about what they were really needing. And how did that come out? How did that then materialize with the M4A?
Yeah, so I think a couple things. I mean, on the overall, ARM front, I think, as Andrei said, we had, the T2A a while back. We've been hearing for a long time, as ARM moved into the server market, right, that you're going to have better price performance for these type of workloads. But what customers really were looking for, from us was one, massive scale, right? So can we roll this out kind of everywhere? And then really, can I run just my normal kind of general purpose workloads on this, right? Can any kind of workload, we've talked about, Nginx, microservices applications, right? Can we run that? But, we had some complaints on, well, I also want to make sure that these machines are way more flexible, right? And this was feedback from earlier designs, right? How do we ensure that I can have whatever kind of mix, if you will, of, if people who know about the cloud, you typically pick a machine shape, right? So on some of our Intel machines, you may pick an N216. It's going to have specific, this with 16 cores, right?
Yeah.
That's what you get, and like 4x the memory, I think, right? So it's an NT16, 64. And a lot of times, right, you don't necessarily need like those ratios, right? So how do we make this way more flexible in terms of that offering and the shapes that people can use? I will say also, and then how can you, one of the things that we've added in there, and maybe Andrei, I don't know if he wants to talk a little bit about this, but was also in the overall design wasn't just the ARM part, but also doing network offload, right? So we can focus specifically on processing power just for your applications and offload all the network processing. We even have better price performance than you see.
If you could elaborate on that, Andrei, that'd be great.
Yeah, so C4As and N4As are part of our newer generation virtual machines. What it means is they're powered by Trainium, which is effectively us taking all the network-related tasks and all the storage-related tasks away from CPU calculations. So you get more CPU horsepower out of those instances and offloading the network I/O and the storage I/O back to the dedicated hardware. That allows us to scale our networking independently from the cores. It also allows us to have a lower latency to our storage. Additionally, all the newer instances on Google Cloud are powered by Hyperdisk, and Hyperdisk allows us to scale our IOPS independently from the size of a volume. Additionally, Hyperdisk Pool allows us to do fin provisioning. So when you look at workloads, specifically that potentially don't use a lot of data or they have repetitive data, the combination of all these innovations allow you to have the most performant core possible, more cycles dedicated to your workloads, and the rest of the stuff is taken care of by Google, either infrastructure like Kubernetes Engine or platform as a service like Dataproc or Dataflow.
I'm going to come back to you in a second, but Gary, I want to come back to something that we were just talking about, and that's related to price performance and how that compares to x86. And we got to be careful about the marketing here, right? Just to make sure that we're talking about what's real. But there's some interesting data there about price performance for web servers like Nginx. Can you talk to that?
Yeah, I mean, we've seen some, again, especially with things like, the M4A, we can talk a little bit about the C4A, but remember, a lot of these applications, right, work well with, per core kind of performance, right, when they're looking at parallelism. So when you look at what you can get out of that, that's obviously going to reduce the price, decrease the overall pricing and increase your price performance. So we're seeing with like Nginx and typical web servers, I believe, 90% improvements in price performance. Another heavyweight in there is my old friend or new friend Java, which is also well known to be a little bit heavy.
Yeah.
Right. So the great thing of porting the JVM to run on ARM a while ago, and now getting about, I think we said 85%. Price performance improvements with that. And those applications are a natural fit, right, because they're generally rely on sort of per core and binding threads to cores.
So Andrei, one of the interesting topics that I find about all of this is when you think about data analytics, right, and you think about the batch jobs that are associated with it. And I was doing some research with you all about Zoom Info. Can you use Zoom Info to illustrate, about those data analytics and batch processing capabilities?
Yeah, I believe they're our first reference customer who has gone publicly to say that they saw a 60% improvement in the overall price performance ratio. It's also worth noting, while they are one of the customers who is coming forward, generally speaking, data analytics workload ETL pipelines are all CPU heavy driven, and they're a perfect fit for an ARM architecture. So a lot of our partners in the ecosystem who depend on Kubernetes to run their ETL pipelines have adopted C4As and N4As for improved performance, as well as our own native cloud workloads, such as Dataflow, which is our ETL pipeline product platform as a service, as well as Dataproc, do take advantage of C4A, and we do see a performance increase as well in that particular space. And again, kind of going back to faster memory, dedicated cores, amazing storage, combination of it all allows you to run things much faster at a much lower cost.
So let's go a little. Let's dive a little deeper into the C4A, because we've talked about the M4A. Maybe we could get a perspective on how it does deliver that high performance. What is it about it that makes it really appropriate for large-scale databases and in-memory cache and those kinds of things? Maybe that's a question better for.
Yeah, maybe you can help me out a little bit about the magic of the memory.
Magic of the memory,
inside
for
of
the
your,
C4A.
Instead of our secret sauce, which is shared by you. Yeah. But again, the magic starts for the databases, most database engine, if you look at the commercial ones as well as the non-commercial ones, they don't necessarily benefit a lot from a hyperthread. So a C4A instance is always dedicated high-frequency core, dedicated core. The second component of this in C4A do allow you to have high memory instances, which allows you to cache a lot of stuff in RAM, and due to the power of the memory, that is the secret sauce of ARM, it allows you to also retrieve it a little bit faster.
Yeah. And I think, add on to that, so the one point that Andrei mentioned about hyperthreading, so with ARM, like I said in the beginning, that you get like a physical dedicated core for any of your workloads, right? So you essentially get more compute to kind of play around, and it's efficient by design, so you get essentially better performance. So that kind of contributes to that. Again, not going into too many details, but yeah, that's essentially the sum of it.
So with C4A then, how is it performing on GKE?
Yeah, so we've seen both, the N4A and the C4A, have great performance for GKE, right? I think it's a mix and match of the, types of workloads that we need, right? We have a lot of customers who have started to look at this for the more compute-intensive workloads are using C4A. And again, some of the good price memory, CPU to memory ratio there, higher density, are great for computational workloads, reducing a lot of that kind of price performance requirements. And then from a GKE perspective, I think people love to use Kubernetes. You still got to orchestrate all this magic, right? You're not just running one machine, two machines. How do I just in time, scale these out, right? How do I provision more VMs, more nodes, provision them with the right shapes and sizes? So we're seeing, a real uptick, in that.
Yeah, we're seeing a real acceleration in the uses of microservices, for instance, right? This seems to apply to this story.
Oh yeah, for sure. Microservices have been, as we talked earlier, this architecture involves a lot of containers, smaller containers, and a lot of them have been about horizontally scaling sort of these components, right? Running more instances of them. Clearly, you don't want to go to the old school way of over provisioning, right? 15 servers.
Right.
Run that. What if I can sort of, just provision when I need them and when I need to scale?
Yeah.
And if we can mix and match the right size node, right? My pod needs 1 core and 2 gigs of memory, right? Only provision that amount, and then when I need to scale, provision more and more, right? And that's one of the things about the sort of N4A. And then on the compute-intensive workloads, we'll see the same thing, right? And again, we can just we can mix and match those. So you can run databases, batch jobs on one set of compute. And you can run on the C4A, and you can just as easily run your microservices on the N4A all in the same cluster.
I just wanted to also add that Kubernetes has the automatic capability of scheduling your workloads. If the AI target for ARM, it will find the node pool for ARM and make sure that it uses the most cost-effective resource effectively to power your workloads, which will translate to secret dollars appearing in your budget to do more with less.
So, secret dollars, I like it.
Yeah, there we go. So let's discuss some AI, ML inferencing. We were talking about, I was talking a little bit earlier. It's come up a few times at the conference already, and how inferencing is going to be done by millions and millions of companies at some point, right? We'll all be kind of thinking about how do you do inferencing. So I'm thinking about how does Axion fit into the AI ML world?
Yeah, absolutely. Great question. So the latest, as you probably know, is agents. Everybody wants to run an agent.
Yeah.
Everybody wants an LLM somewhere or some sort of machine learning model. What not everybody is realizing is part of your agents and your agent orchestration systems agents will have tools, and those tools will call other things, potentially just classical machine learning models that technically don't always need to have a GPU behind them. Secondarily, from an inferencing perspective, GPU come with VRAM, and sometimes that VRAM is not sufficient for your workload, or it's the opposite, too big. And cloud, after all, is all about efficiencies and gains. So if you're seeing an underutilized GPU, there's a lot of workloads that can benefit, specifically smaller LLMs that could be inferencing on CPUs. If you don't have a clear need for low latency out of the response and more of a job that relies on batch, you will potentially see that the C4A instance will be a much cheaper alternative versus you renting a GPU. Similar fashion, if you are running tools or you're running a RAG or if you're running embeddings, a CPU is just as efficient to be able to do the pre-work, the pre-queuing before it sends data to the LLM. And again, you kind of decoupling your tools and processes and only using the right things when it matters, and not necessarily just throwing everything all to the GPU or suffering the performance downgrades of a CPU-based inference. Yeah. So smaller jobs, experiment, and you'll find a clear path.
Would you like to add anything to that?
Yeah, I think he covered it pretty perfectly. But I think one more thing is that with inferencing, and especially that's the message we want to land, that whenever you hear AI, you don't need to run a 3 billion parameter model on a GPU.
Right.
You can do that very well on a CPU,
yeah.
And you can go beyond that. So inferencing is well supported. So one more thing in addition to that, other than the LLMs, is about any traditional use cases or MLPer, for example, recommendation engines like DLR V2. They are highly optimized for ARM, so you get like much lower latency with Axion, and you get better performance in there. So again, I'm going back to that performance and efficiency story, but the entire landscape of AI/ML kind of fits well in that story.
So I just want to follow up on a question on like relates to edge AI, and is this applicable to the edge AI, or is this mostly for cloud-based data centers, or are we thinking about this capability useful in deployments such as edge devices, or is it more applicable to the data center?
So it depends. So by edge, do you mean like running your models on the edge on ARM?
Yeah, I mean if you're like let's say you're like I'm in an industry, let's say I'm in the auto industry, and I want to be able to use, I want to be able to apply this to my factory, for instance, and such, and then actually have the instance there at the factory.
Yeah.
Is this applicable to that?
I mean, yeah. I mean, ARM architecture is present at the edge
Basically,
as well. Yeah. So you can, in theory, you can run it.
Yeah.
But again, we have to look at the form factor, what kind of models you're running. You need to quantize the model to be able to run it in such a smaller factor. And we have, so ARM has libraries, Kleidi AI, that runs underneath. So you can take advantage of that and run at a very efficient fashion, even at the edge.
Yeah, I just wanted to add also, Google has been famous for the use case that you're describing. I believe everybody knows we own Android.
Right.
Android has been making strides in running local LLMs on top of cell phones.
Right.
So if you look at the Pixel 9 and now 10, they will run a local version of
right.
Our model paired with a CPU that's ARM-based.
Yes. Yeah.
And most importantly, we also have MediaPi, which will allow you to adopt the same technology, whether it lands on top of an Android or an iOS. And we do see quite a few customers asking for this use case. Google's belief in that particular space is multi-tiered, I would say. So there are certain things that would be great on top of a cell phone. Then more powerful devices might be needed from our partners. Google also has distributed cloud, which will leverage a combination of CPU and GPU to help with your needs and bridge the gap where horsepower is needed at a lower latency.
All right, well, let's move on. So, so I wanted to ask you, Gary, about this concept of custom machine types and why they're important. What makes them interesting for using them in the M4A?
Yeah, and I think we alluded to this a little bit earlier, but again, we've talked a lot about what people really want to be able to do is be able to right size the compute for their kind of workloads, right? And workloads come in all kinds of different sizes and shapes, right? And you also, as you mentioned, we want to be able to provision, more on demand, right, and not have to pre-provision, right? So with custom machine types, we're able to basically kind of mix and match that sizes, right? You're no longer limited to fixed shapes. This makes it really easy for us, from a Kubernetes perspective, to pick a node that's going to perfectly match whatever pods we needed scheduled, which is going to, of course, we already talked about the price performance in general, but now we're reducing any extra spend, extra cores or over provisioning, and then we're able to provision more and more of those. And the other nice thing, I guess, just to chop up the Kubernetes side on there, is that one of the big things that we have been working on GKE for a long time is what we call node auto provisioning, right? And very much like it used to be in the old days where people you buy 15 servers from somebody that are of this shape and you just provision them out there. That's kind of how people looked at things from a Kubernetes perspective. I'm going to use this node and it's going to have 32 ARM cores and 64 gigs of memory, even if I only deploy a pod with 1 core or whatever, and I've got 63 extra cores left. So we've always been the ability to say, hey, based on your workload, we will find and pick the right machine shape for those workloads that are in the backlog. Now we have the ability to customize that shape even more, which is going to greatly reduce your costs.
One of the interesting aspects of ARM is how it, is questioned, I think, maybe a little bit about how difficult it is to use at times, maybe in the data center environment. But you have simplified multi-architecture images in quite a significant way. Like, for instance, how difficult is it to build a multi-architecture manifest, in Docker, for instance?
It's single line change. Can I say that? No, just wondering. No, but it's very simple. I think the notion comes from it where people who are on the legacy architectures have been in the past. They feel that resistance moving on to a new architecture, that it's going to be a much more heavy lift compared to a straightforward answer. It is, in majority of the cases, is a straightforward thing. If you are building your images in a multi-architecture fashion, that can go to both x86 and ARM64, you can deploy it seamlessly. If you are cross-compiling your applications from one architecture to other, there are, let's say, a Golang-based application or a Python-based application, you just have to recompile it, make sure that there is an ARM binary that can exist and can be deployed. It's not a heavy lift. We did a workshop yesterday, which we were talking about, that migrating to ARM or Axion, it's not that hard. You just need to start and then just go forward. And we have so many resources. We can help with that transition too. And I'm sure the Google guys can.
Yeah, I just wanted to also know that we absolutely agree with everything you're saying. Google has been on its journey to transform to ARM as well. A lot of our services that we pick to battle test ARM for our native services have gone through the journey. We're seeing tremendous results. So it's not only you consuming it in Kubernetes or other services in the cloud. Google eats its own dog food. We've been eating it for a while. We see a tremendous amount of performance increase in our number one products like BigQuery, Spanner, and the rest, and not the ones that you see in the cloud, the stuff that actually powers everything under the cover for our for our normal Google services.
I guess in conclusion, we're running out of time. So Gary, how can developers and platform engineers here, learn more about M4A on GKE?
Well, the easiest way we have, just go to our site. We got great, great blog on how to do it. Sort of great tutorial, and follow through on sort of getting started. But it's just available for people to easily get started. We have examples of how to build ARM-based images, or even cross-compile them. Simple way to configure this with a thing we call compute classes, just to annotate their pod spec. And then the magic will happen. We'll automatically provision those nodes for them because they're the best because we look for the nodes that match with ARM and best price performance.
And if you're not Gary and you don't know how to use Google Cloud, there's always the Cloud Assist that will be there to help you gentle your way into our ecosystem. And don't forget our Cloud Assist as well. That could hypothetically help you at least merge to 80% gap to convert to something that's other than x86.
Well, thank you guys for chatting a little bit about Axion and its direction. Thank you very much.
Yeah.
Thank you for having us.
Thank you for having us. Thanks, Alex.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.